here to talk about today is a manufacturing technology partnership. When I look at this slide, you know, we all live in this manufacturing universe. We have technologies that we have to use to manufacture our parts, and you know, two of those major technologies, one would be the cutting tool and the other is the software. And today Mastercam and ISCAR, we're here to talk about a partnership that we created to create better utilization from a programming standpoint and from a cutting tool standpoint. We're going to show you two things today. One is about groove turn programming, and then we're going to move into high-speed machining, what we're calling high-efficiency machining. And I'm going to let Steve say a few words about the partnership before we get started.
Thank you, Tom. One of the advantages of having this partnership is the fact that we're taking the technologies, the software technology as well as the tooling technology, and we're making one interface point so that a user can take advantage of both those technologies at the same time. It's not often that you'll have an applications engineer from ISCAR by your side when you're doing the programming, or an applications engineer from Mastercam by your side when you're doing the programming, and even rarer that you'll have both of them on either side of you while you're doing that to take advantage of both their technologies. So the result of this partnership is we've taken the technology that ISCAR provides and we've enhanced the technology that Mastercam provides to take advantage of the tooling.
I'm going to narrate while this video is playing in the background, but something that ISCAR developed mid-1980s was the ability to groove and turn with what you might typically view as a grooving tool. And this is a technology that has not been utilized to the fullest potential, and the big bottleneck has been programming. Most of the programming of this type of tool motion is done by hand. So it's a bottleneck, and we needed to address it. And one of the things we did was approach Mastercam and say, can you take our rules of engagement, how we want to apply the tool, and can you create an automated way of programming this tool in your system? And they took that project on, and I think you'll see an example later on how they've done that very well. What you just saw in the previous video was kind of like a rough and finish type motion, and what you're seeing here is a near net shaped part, a camshaft, where we just need to apply the finishing principles of the groove turn motion to finish the part. Okay, so to get started with groove turn, programmers need a basic understanding of our grip lines. What products do we have that apply to the groove turn programming? The grip applications, and you're sitting here going, okay, what is it? Turning? It's turning. You've seen that, and we can perform external, face, and internal groove turn operations with our tools. And grip programming, I told you there's some rules of engagement, and what you saw on the screen, there's some little intricate moves. You got to pay attention to detail to get the most out of this programming. So with grip lines, I mentioned that this is something that we created a long time ago. We started out in early 1970s with self-grip, and we moved on through, and in 1985, you'll see I've highlighted this Hela grip, or cut grip. We came out with the ability to groove and turn. So since 1985, 25 years, we've had this ability, but it's never been easy to program, or there's never been a robust CAM software to address the programming needs. As I told you before, the applications, external, face, and internal. There's some things you need to know. Make sure you pick a tool that's capable of what you're looking for. And to get started, you need to get to know the icons. If you look in our catalogs, there's going to be icons that call out parting, groove turn, threading, and grooving turn with a full profile, round insert. This is a grip icon for an external turning application. These grip icons cover the internal. You can see they've changed a little bit, but the basic idea is we've got icons that call out what that tool is capable of. And then for face turning, another set of tools to cover the face turning applications. And so what are we looking for? we're looking for the icons for groove turn that show, you've got multi-directional capabilities. Told you that there are some programming techniques that need to be taken into consideration. When that tool engages the material, the first motion is a grooving motion. The feed and speed will be reduced compared to the turning motion. But the first thing you do when you groove is you have to back away from the part. We recommend 8/1000ths, and then you start the side turning motion. And then what happens is the side turning, it creates deflection. So when you get to the end of that cut, you need to vector away from the part rather than come straight out, or you'll drag the insert out, or you potentially could drag the insert out of the pocket. And then you would continue that motion, so on and so forth, until you roughed out between the walls or the groove. Now when you get to the finishing motion, you can see that we have a very specific set. We want to finish to the diameter, then we want to come back up and approach the vertical walls. Covering the finishing again here, groove to final diameter, pull back the tool, and then what we have is we call it a delta move. I mentioned the tool deflection the insert undergoes when it gets into a side motion, and this needs to be taken into consideration. It's usually maybe between 5/10ths and 2/1000ths depending on the width of insert and the material that you're engaging, but it needs to be taken into consideration. If you think about that tool tilting into the material, you need to pull back away a little bit and then come across the part. This formula right here is what we use to determine what that number is. With face programming, you need to take into consideration the arc on the holder. You can see here we've got the radius, and we'll have a diameter max and a diameter min that tool is capable of plunging into and then starting the turning motion. We'll give you recommendations. It's kind of simple. The maximum, the programming feed and depth of cut. You can look at the maximum depth of cut. It's the width times 0.65 of the insert, and then with the feed, it's the width times 0.075. So it's simple calculations to come up with your depth of cut and your feed rates. Now I mentioned that the tool tilting, and this picture right here kind of simulates that. And what we need to do when we're finishing is we need to make sure we're leaving enough material, and we need to make sure that we're feeding at a feed rate that's enough to create that tool deflection. And this chart here kind of gives you some ideas what you need to do through the range of inserts. Why should you care? What are the benefits? This is a system that's designed to eliminate tooling. That simple video I showed you in the beginning, you might use 3 tools to do that. Maybe you would use that one rougher to do the rough groove, and then you'd come in with a right and left hand tool to finish the sidewalls. We can do that whole process with one tool. Increased utilization. If you notice that zigzag motion, you're using 3 edges of that insert. It's got 3 sides to it. Typically, we have users that only groove, so they only ever use the face of the insert. If you remove the material using 3 edges, you're increasing your tool life. And then we can hold tolerance, and we can create fine surface finishes because of the nature of the cutting action. With that tool tilting, we get what is a wiper in effect, and we hold 32 micro finish with this with no problem. All right, so I'm going to pass it on over to Steve, and he's going to show you how we've made the programming easy.
What I'm going to do is I'm going to demonstrate how this programming is done inside of Mastercam. As I stated earlier, what we're bringing to the table is the experience, the knowledge that the ISCAR tool brings to the customer. As Tom indicated before, this tool's been around for quite some time, but the difficulty in using this tool was the programming, taking in consideration that back off amount and using the tool appropriately so you can maximize the productivity gains that this tool can give you. Actually, what I'm going to do is I'm going to go to my plunge and turn. If I go to the parameters, there is an actual plunge turn option inside of Mastercam. And then I will select the appropriate ISCAR tooling. And if you're a Mastercam user, you're going to recognize many of these dialog boxes right off the bat, in particular your entrances, your exits. But this is a new tab. And these are the plunge tool parameters, although there are many similar functions as far as stock to leave in both X and Z. The one thing that's important that we need to understand is that for roughing, there's certain methods as to how you enter the part. Again, Tom was mentioning how you can go back and forth, you can zigzag and cut through and rough the part. If we go to the last tab, the finishing, the important number that we need to pay attention to take advantage of this tool is what we call the tool deflection back off, or as Tom puts it, the delta move. This information you would get from your ISCAR catalog, and based on the material and the amount of stock that you're leaving, you'll put this number in here, the appropriate number, and then you would go ahead and calculate the tool path. So let's just take a look at what this tool path looks like. Oh, first I'm going to regenerate it because I made a change there. So I've recalculated this tool path live. And now I'm going to do something that's called a back plot. And what back plot allows me to do is take a look at this, and I'm going to step it through one step at a time so you can see the stock. Let's just zoom up on the area that we want to take into consideration here. Now let's just step it through, and you can see the tool. Did you notice that little retraction right there? It's not just a motion, a straight motion, it's actually going at 45 degrees. I will continue to step through, so the tool's being used the way it was designed to be used, and I think that's the critical differentiator that we bring to the table here, is that we can really take advantage of what the tool does. I can see we're going to come back, clean up all the plateaus, and finally we're going to come down the sides. Notice that back off amount? Let me zoom in here. Come back. I'm going to step it through. And then you'll notice there's that back up amount. Very small motion to clean off that floor. So as you can see, one tool to do this entire form very efficiently, one operation, one tool, and finished. Tom asked me to show how some of the parameters are built in to perhaps use this tool more appropriately or safely. So we put in some checks here, for instance, stock to leave. And the trick here is ISCAR recommends that the stock is larger than the corner radius of the tool. So what would happen if I change this? Let's make it a little bit smaller. Mastercam has a check here. Although I can override this, the intelligence is built in to say, oh, you're not using this tool appropriately, you're not going to get the results you need. So that we built these safety measures, and these are in through the entire interface, so this tool gets used appropriately. Let's say if I make my depth of cut more than what ISCAR recommends, again, and here's the rule of thumb. The more than 60% of tool width, ISCAR recommends you don't exceed that. So again, we're ensuring that we have a fail-safe approach to programming this tool correctly so you get the best results. So again, if you're a Mastercam user, many of these controls are familiar to you. The only difference here specifically are with the plunge groove tooling, and it's only enabled when you use the ISCAR tool.